Hey everyone, Mr. Voikin here. This is lesson 1.5 on fractions, and we're going to take a look and learn about fractions and how to use them in mathematics. So, what is a fraction? Well, a fraction is a part of a whole. So in math, it's part of a whole number. So let's take a look at this visual we have. We've got a rectangle, and we would say this is an entire rectangle, one whole rectangle. But anything that is whole can be broken down into smaller pieces. So if I was to cut this 6 times, we would end up with 7 pieces. So that becomes the denominator, or the bottom number of the fraction. And if I'm to color in 2 of these sections with red, that colored section, there are 2 of the 7 that are colored. So that is the fraction that represents what you're seeing there. Now, if I was to color in another 3 in green, we would say that 3 of the 7 are green. Now, how many of these sections of the larger rectangle, or the whole rectangle, are shaded red or green? Well, we would add those together. So we got 2 reds plus 3 greens, so we end up with 5 of the 7 are shaded in. So 1, 2, 3, 4, 5. Now you will run into 3 different types of fractions. Okay, so we are going to take a look first at proper fractions. So what is a proper fraction? Well, it's a fraction that has a numerator that is smaller than the denominator. So what is the numerator? Well, the numerator is the top number, and the denominator is the bottom number. So you can see here we have a fraction that is 3 over 4. We also say 3/4. The next one is 1 over 2, which is 1/2. That followed by 7 over 9. And we can also have negative fractions, so a negative 5 over 6. Okay, but in every case, in this situation, the numerator is smaller than the denominator. Now let's move on to improper fractions, and that's just the opposite, where the numerator is larger than the denominator. So the examples that we have are 4 over 3, 6 over 5, 18 over 7, and again it can be negative at negative 21 over 2. So in this case, what do we see? Again, we recognize that the numerator is larger and the denominator is smaller. So what about a mixed fraction? Well, a mixed fraction is going to be a number that is a mixture of an integer, which is this first part right here, so the 4. Oops, I can't really see that, so we'll use green, yellow. We have our 4, followed by a proper fraction, 3 over 5. You're never going to have a mixture of an integer and an improper fraction, okay? So negative 8 and 3/16 and 7 1/2 are also examples of mixed fractions. All right, so let's start doing some work with fractions, and the first thing we're going to do is learn how to convert between the different types. So in this case, we have an improper fraction, 13 over 3. It's an improper fraction because the numerator is larger than the denominator, and we are going to be converting it into a mixed fraction. So what we need to do in this case is divide the bottom number into the top number. So how many times will 3 divide into 13? So the answer is, in this case, 4. So it goes in there 4 times. Now 3 times 4 is 12. So we're taking out 12 of those 13 pieces. So we subtract those 12 pieces. How many are left over? 1. Okay, now the denominator needs to stay the same, so we had a 3 right here, and it needs to be a 3 over here. And 13 minus 12 is equal to 1, so we have 1/3 of the little pieces left over. Okay, now these 2 fractions are in different forms, but they are completely equal to each other. Now let's do this again with the second one. We got another improper fraction, 17 over 2. We're going to divide the 2 into the 17. Now we know that 2 can divide into 17 8 times. 8 times 2 is 16, so I'm going to now subtract 16 from the top number. Remember, my fraction part of the mixed number is going to have the same denominator, and 17 minus 16 is 1. Okay, now we're going to take mixed numbers and convert them into improper fractions. And to do that, we're just going to take a look at this first example, which is 2 and 5 over 6. That's a mixed number or a mixed fraction. And we are going to take the denominator and multiply that by the whole number. So we're going to multiply this. So in this case, 6 times 2 is 12. Okay, now what are we going to do with that 12? Well, we are going to add it to the numerator. So 12 plus 5 is 17. So just like with when we're converting from improper to mixed, the denominator needs to stay the same. So we need to have a consistent denominator. But in this case, to figure out the numerator, again, that's 6 times 2, which is 12, plus the 5. The numerator is going to be a 17. Okay, let's do this one more time with 4 3/4. Again, what are we going to do? Multiply the 4 by the 4, which gives us 16. And then we're going to add the 16 to the 3, which gives us 19. So, to make an equal fraction in an improper form, we're going to keep the same denominator, which was 4, and our numerator is going to be 19. Okay, so right now we're going to take a look at fractions and how to recognize if they're equivalent, which means they're the same, and how to reduce them into their simplest form, and also how to compare them to see which one is larger or greater than or less than, which one is smaller. So let's start with the first one up top, which is equivalent fractions. So we have a fraction right now that is 3 over 4. So what are equivalent fractions? Well, basically, it's almost like this taking a number and looking at multiples of it. It's the same thing. So 3 over 4, I'm going to take that and I'm going to multiply the top by 2 and the bottom by 2, and we're going to end up with 6 over 8. So in this case, 6 over 8 is equivalent to 3 over 4. Now, if I was to take the top number and multiply it by 3, that means I would have to multiply the bottom number by 3 as well, and that means we would now have a fraction that is 9 over 12. So in this case, 3 over 4, 6 over 8, and 9 over 12, these are all equal or equivalent. So this one right here, however, 3 over 4 is in what we call lowest or simplest terms. Okay, so let's take a look at reducing fractions, because although these three fractions are equivalent, this is the format that we want to leave our answer in most cases. So if we have 24 over 48, you may be able to recognize right away that 48 is twice 24, which is 24 times 2. So I can reduce this fraction down to 1 over 2. Now, some of you may not be able to see that right away, so what we're going to look for is common factors that will divide into the numerator and the denominator. So this would be using your divisibility rules, and an easy one to recognize right away is 2. Okay, so you can see that I can divide this by 2 and divide that by 2. That will keep them equivalent and just make it smaller. So that's going to equal 12 over 24. Now both the numerator and denominator are even, so I can now divide by 2 again. And I end up with 6 over 12. And again, I can do some division, and eventually I will get down to 1 over 2. Okay, now what about comparing fractions? Well, with comparing fractions, I'm trying to see which one is larger or smaller. So I want to put one of these signs in there, and quite often they could be equivalent or equal as well. So to do that, what I need to do is I need to have this denominator the same. And the easiest way to do this is just to multiply the one denominator by the other denominator. So in this case, I would multiply the 7 by 11 and the 11 by 7. And by doing that, I'm going to get a 77 on the bottom here and a 77 on the bottom here. That's because 7 times 11 is the same as 11 times 7. Now remember, if I multiply the bottom number, the denominator, by 11, I also have to multiply the numerator. And on the other fraction, if I multiplied the denominator by 7, I would have to multiply the numerator by 7. So the first fraction, 5 times 11, is 55. And with the second one, 7 times 7 is 49. So now that I have equivalent fractions right here, they both are out of 77, I can see that 55 out of 77 is greater than 49 out of 77. All right, now here we are at adding and subtracting fractions. So some people find this quite easy to do and some people find it quite difficult. But I'm going to show you a method that will hopefully make it easy for you and give you some success. So what we need to do when we're adding or subtracting is we need to take a look at the denominator. Okay, so we need to have the same denominator. In this case, 4 and 12 are not the same. So we're looking for what we call the lowest common denominator, the LCD. So if I multiply 4 by 3, I will get 12. And then that will be equivalent to the denominator on the other fraction. Now remember, if I multiply the bottom number by 3, I have to multiply the top number by 3. So if we are to rewrite this one right here, we are going to get 9 over 12, and in this case we'll add it to the 3 over 12. So the 9 out of 12 would be like 1, 2, 3, 4, 5, 6, 7, 8, 9. And the 3 out of 12 would be 1, 2, 3 little pieces. And you can see we've covered in all 12. And all we do here is we keep that denominator the same. So we need to have a 12, a 12, and a 12. And I just add the top numbers. 9 plus 3 is 12. Now, whenever we get to our final answer when we're doing fractions, we have to ask ourselves the question, is this in the lowest terms? Well, it's not. I can see that 12 over 12, and remember this line right here, it means to divide. So 12 divided by 12, that equals 1. Okay, so what about subtracting? Well, it's the same thing. We need to have a common denominator. Now, in this case, the easiest way to get a common denominator is to multiply the 2 by 11 and the 11 by the 2. Okay, so again, if I multiply the 2 by 11, I have to multiply the top number by 11. And if I multiply the 11 by 2, I also have to multiply the top number by 2 as well. So I'm going to rewrite these two. 1 times 11 is 11, and our common denominator is going to be 22. We're going to subtract from that, again, a common denominator, and we're going to end up with an answer that has a common denominator. So 22, 22, and 22, they all have to be the same denominator. So the second fraction is going to be 2 times 2, which is 4. And the difference of these two is going to be 11 minus 4, which is 7. And now I have to ask myself, well, is this in simplest terms? Well, the only numbers that can divide into 7, because it's a prime number, is 1 in itself. 1 will not change anything, but 7 divided by 7, I can do that. Can I divide 7 into 22? No. So this becomes our final answer. Now, what if we're asked to add fractions, but they happen to be in mixed form? Well, in this case, we're going to need to do two things. First, we need to put these fractions into an improper format, then get a common denominator, then we're going to add them together as we did above. So how do we do this? Again, well, we have 3 times 4, which is 12, and we have 12 plus 1, which is 13, so we now have 13 over 4. And we're going to add to that by doing the same format. 2 times 2 is 4, and 4 plus 1 is 5. So this becomes 5 over 2. Recognize that they do not have common denominators, so I can just multiply the 2 by 2 to get 4. Now they will have common denominators, so I'll have to multiply the top by 2 as well. So if I rewrite this one to the right here, I have 13 over 4 plus 10 over 4. Yes, the answer has to have the same denominator, 4, 4, and 4. And I'm going to now add those together. So 13 plus 10 is 23. So the answer is 23 over 4. Now, if you're allowed to leave it in improper form, you're finished. If not, we may need to take this and put that into a mixed number. And how do we do that? Again, well, we divide the 4 into 23, and the 4 can go into there 5 times. So my whole number becomes 5. Don't forget, we're going to have that same denominator of 4. 4 times 5 is 20. So what do we have to do? We need to subtract the 20 from the 23, and that will give us our numerator, which is 3. Okay, now we're on to multiplying fractions. You'd think this would be harder, but it's actually easier because we do not need a common denominator. So all we're going to do really is we're just going to multiply the top numbers through, multiply the bottom numbers through to get our answer. So on the top, in the numerators, we have 3 times 5, which is 15, and the denominator is going to be 10 times 9, which is 90. And again, what did I say? Always ask yourself, can I reduce this down to simpler form? Well, recognize that we can see one number ends in a 5 and the other in a 0, so the divisibility rules tell us that we can divide both numbers by 5. And if I do this, we're going to end up with an equivalent fraction that is 3 over 18. Okay, now are we finished? Well, we have to say again to ourselves, is this in simplest form? Well, 3 is a prime number, so 3 can divide in there. Can 3 divide into 18? Well, divisibility rules, 8 plus 1 is 9, and 3 can go into 9, and you should be able to recognize that 3 can go into 18 anyways. So we're going to divide both of these by 3 in this case, and we're going to end up with our final answer in simplest form, which is 1 over 6. So although these are all equivalent, the one that is best answer is the 1 over 6. Now there is a little bit of a shortcut that you can do before you start multiplying. So I'm going to do this question again right here. Okay, now notice that what we have here is we've got these numbers on top, so a 5 and a 10. And I can see that I can divide 5 into 5 and 5 into 10. So if I divide 5 into both those numbers, I'm going to get 5 divided by 5 is 1, and 10 divided by 5 is 2. Okay, and notice that we have on the other side here a 3 and a 9. Okay, so 3 divides into 3 one time, and 3 divides into 9 3 times. So now by canceling out prior to doing the multiplication, you can see that what we have right now is 1 over 2 times 1 over 3, and when I multiply the top through, I get 1, and when I multiply the bottom through, I get 6, and we're already in lowest terms. But I would still ask myself, am I sure I'm in those terms, because I may have missed something in my initial steps. Okay, now another word that you might come across is this word of. And basically what of means is times. So what is 3/4 of 5? What that really means is what is 3/4 times 5. Okay, now the number 5 is a fraction, or can be put in fractional form just by putting it over 1. And now I'm just down to simple multiplication of fractions. So I check, is there anything that can be divided into the top and bottom equally? In this case, the answer is no. So I multiply the top through, I get 15, and I multiply the bottom through, and I get 4. In this case, we are an improper fraction. So again, how many times does 4 divide into 15? It goes in there 3 times equally. 4 times 3 is 12. So I'm going to subtract the 12 from the 15. I'm going to keep the same denominator, and 15 minus 12 is 3. So the answer is 3 3/4. Okay, we are on the last part of the lesson, so we are going to look at dividing fractions. So in this case, we have 3/8 divided by 1/2. Now you might also see it in this form, 3/8 over 1/2. So both of these are the same thing, just written in different ways. Okay, but we're going to take a look at it lined up horizontally here. And how do we divide? Well, there's one step you have to do that's going to make this really simple. You'd think you would just go 3 divided by 1 and 8 divided by 2, but that is not what you do. Okay, so what we're going to do is we're going to take this second number right here, and we're actually going to turn it upside down. Now, you won't be able to physically turn it upside down like I just did there, and numbers end up backwards anyways. So we will rewrite this as 3/8. And remember what I said, turn this one upside down, 2/1. And now we're going to take this, what was a division sign, and we're going to replace that with a multiplication sign. So what are we doing? We're flipping that and changing this. And then you just follow the rules. Well, I look right here, 2 can divide into 2 one time, 2 can divide into 8 4 times, and then I'm going to multiply through. I got 3 times 1 is 3, and 4 times 1 is 4. So let's do one final example. Remember, we're not going to change the first fraction. We're going to change the division to multiplication, and we're going to flip the second fraction upside down, and then we're going to look for anything that can cancel. 4 goes into 4 one time and into 4 one time right there. I can't do any more reducing, so I'm just going to multiply straight through. 1 times 3 is 3, and 7 times 1 is 7, and that is our final answer. Double check. Yes, 3/4 cannot be reduced down. Double check. Yes, 3/7 cannot be reduced down. So finished and finished. Okay, so I'm going to pose a challenge question to you and see who can get this done. This is not mandatory. You do not have to do this. But if you want to have some fun with math, try this question out. So inside brackets, we got 3/4 times 5/6 divided by 2/3 minus 7/16, and we're going to square that. So don't forget that you're going to have to use BEDMAS rules. See you in class.